Hi everybody, it's time for an update on my solar project. If you've been watching the previous couple of segments, I've been talking about my battery, my solar, and how I put everything together. Now it's time to update you on how it's going on. So we've been camping for 5 days now, and we've been running purely off a battery. We have been driving a little bit, but most of the charging was done through the solar panels. I do have a charger. I haven't done the video on the charger yet. I do have a charger in my car that I've done in a previous video, where I just have a standard AC charger plugged into a AC inverter that gives me the ability to charge it without having to modify any of the car's infrastructure. And I'll show you that in another video that I'm gonna do just on that charger itself. So let's take a look at how we're doing. We got our fridge running right now. It's running. It's been running at this stage for a couple of days. I started it as a freezer because we did have frozen food with us, and day 5 I slowly ramped the temperature up to 3 degrees Celsius so that it's not burning as much battery as it was when it was running as a freezer. As you can imagine, it drew quite a lot of power. I got my battery up here. Right now we're pulling in some solar panels are right there down the cable. Yeah, it's a bit of a long cable, but no other choice because there's no sun where we're at on this spot. So what are we doing here? Let's see. The charging mechanism is doing about 2.6 going in. The fridge draws, it kind of hops between like 2.7 and 3.2. I'm just calling it 3 amps most of the time. When a fan turns on, it does go to 3.5 or 4 amps. Well, it jumps between 3.5 and 4. So, but on the average, it's just pulling 3 amps. So I added this little addition here. So this is my battery charger. This is for when I'm charging in the car. So I have to unplug everything, of course, and put the battery charger on. And yeah, that is how that thing works. We've been able to probably get about 12 amps a day back into the battery most of the time. All right, so the fridge is probably, yeah, the fridge is at its temperature. It's showing 12.3 volts. We're showing 12.5 volts on the battery. So that means we're probably about 80%. We started this morning at, whoops, let's not do that. We started this morning at about 12 volts. It does go down to 12 volts now overnight, but I quickly can charge it back to about 12.5. I'm not getting to 12.7 because there's just not enough sunlight, and because this solar panel is not pulling in enough power. So I have a ticket open with the manufacturer. They're surprised that this isn't a 120 watt solar panel. I think it's not. From all my testing that I've done with the other inverter, I think it's more likely a 60, possibly a poorly performing 80 watt. Because one of these, if I block out the sun, one of these does show up as reducing by about 18 watts, and I did get like maybe 62, 63 on the MPPT controller. So yeah, this solar panel seems to be a bit not what is advertised. Let's see, where does it say? It doesn't say on this side, maybe on that side. It says, yeah, it says 120 watt solar charger, and we'll see. So EcoWorthy have been kindly enough to respond to my questions, and they are sending me another panel. We've done some measurements on this panel, and they're sort of scratching their heads why it's not producing more than 60 watts. Yeah, so we'll see what they come up with. We'll see what the replacement panel looks like. I do have some concerns about the quality of this panel. You can see that it's delaminating already on the edges here, right? And that's the thing that worries me, right? Because this is, if it starts delaminating, then it's going to start letting in water, moisture, air. I don't leave it out overnight, but still, you don't want your panel to delaminate, because then potentially the silicone will start to degrade much faster, right? Like any kind of electronics, you don't want to expose them to moisture. It's definitely a bad idea. But yeah, we'll see. I'll keep you updated. We'll see over the next few days how this works out. I definitely recommend a 100 amp battery for any kind of long-term off-grid, like my little fridge there. That we had a rainy day, which was pretty much zero power coming in. Then we had a day when we were driving around a lot, and I took the fridge with us, and I was charging it off of the car, and stopping and going doesn't really charge it that much. So yeah, I would definitely recommend a 100 amp battery. Nothing less for off-grid. But you know, if you can get, I'm probably getting about 2.5 amps for about between 9 a.m. and sort of 6 p.m. when I'm able to still get light. So that's about 9 hours at 2.5 amps. So I'm looking, maybe on a good day, I'm gonna get 20 amps back in, 20 amp hours back into the battery itself on this side. If it was a more sunny side, then of course I would definitely be getting back more. As you can see, this is the problem, right? The sun starts moving, and one panel is shaded now, so I have to move this whole system. And yeah, this is basically what I do. You get to see the whole shebang right now. Every 15 minutes I come here and I just pick up the panel and I move it into the sunshine, and I have these bottles to even out the panel nicely, because on its own, on its straps, doesn't stand well. So yeah, this is a little bit of fiddling, and that's why I was hoping that it would be an actual 120 watt solar panel. The size of it should possibly produce 120 watts, right? Because this is about 60 centimeters by 1.5 meters, about 1.5 square meters, so plenty of space. Like 2 square meters, you can get 300 watts off of that. So yeah, it is what it is. We'll see what the manufacturer says, and I'll update you with that. All right, see you in my next video. Bye.